So my name is Kartik. I'm a finishing PhD student here at the Faculty of Aerospace Engineering as well. In the Space Engineering department, we actually have two groups, Space Systems Engineering and the other group. So I'm in the other group. My main background is in orbital mechanics. And this is a little side project that started a couple of years ago that's turned into a spin-off startup from the university. So I'm here to just tell you a little bit about what we're doing, and then hopefully as we progress, it'll become a little bit more obvious what it has to do with pocket cubes, possibly. I'll predicate this by saying that I'm hoping for a lot of input, so I end with a question, so please stay awake. So basically from my own experience, as engineers, we face questions every single day. And they're questions of the nature going down to a component level or subsystem, what a certain parameter value is, all the way up to bigger questions relating to what the trends are in the market, are satellites getting bigger and smaller, what are the hottest technologies, etc. And what I noticed working on preliminary design of a few different mission concepts was that a lot of my education was not being used actually because I was doing a lot of Googling to try and get answers to these questions. And the more I investigated this, the more I realized that I'm not the only person who faces this issue. In fact, this is pretty much the response whenever I talk to an engineer and ask, how do you deal with getting this kind of information? So that's when a couple of years ago we started with the thought experiment. If I can go online and search for a cell phone or a laptop and I can enter in what the screen sizes I want and the disk space and whatever other requirements, I think pretty much every consumer has experienced that, and it's pretty much bog standard stuff. And yet in the space industry, we still struggle to be able to figure out how to find information. So when we went into this a little further, what we realized was that there are different facets to this problem. So it starts with what I'm talking about now, which is sort of search and discovery. And we've talked to a lot of people, professional students, and try to understand what does that actually entail today? What are people doing? So do you have an idea what the number one tool is that people use?
For what?
To find stuff. Google, exactly. So we're all Googling. We're all Google experts here. Secondly, you'll find that people are resorting to asking colleagues. LinkedIn is very popular, reaching out to your space friends, trying to figure out who knows what about this company or what they're providing. And then thirdly, you have all kinds of ad hoc solutions. So somebody who's gone through that pain and aggregated some data and extracted and put it in an Excel sheet, but then hasn't touched it in about a year and doesn't know if the data is relevant anymore or if the company even exists. So it starts at that point, but when you actually go deeper, you realize that it's a full stack problem. Because not only is it about finding, but it's about what you end up finding when you actually look. Do you know what the standard form is in which information is typically communicated within the space industry? So what do you usually look at when you've Googled something and found information? Yeah, it could be a PowerPoint. Very typically, it's a PDF document. It's a data sheet, right? And this phenomena of the data sheet, we've come to realize is a real pain. And more than anything, because there's also no standardization around that, which means that when it comes to the process of actually extracting data out of these data sheets, a lot of very, very intelligent people are copy-pasting numbers, which is time-consuming, which is error-prone, and it really doesn't make sense for an industry that's supposed to be at the final frontier, right? Or heading towards the final frontier. And it gets even worse, because when you pick up 2 or 3 of these data sheets and you put them next to each other, the one thing you notice is that they're consistently inconsistent. There is nothing similar about any of these data sheets. And in fact, you'll find all kinds of different information in there. And most of the time, you don't even know what they really mean until you do what? Anybody have an idea what?
You call them up.
You call them up, right? And this will come to a later point in my presentation. But that's sort of the modus operandi in the industry.
You're describing, this has happened for the last 60 years. We think of space as an engineering it's not, it's a craft. It's like making jewelry. And the way you make jewelry, you make good jewelry, is you have artisans and they train under gurus, and the gurus teach them how to do it. I mean, that's really what you're describing.
So why am I addressing it to this community? Because we are convinced this has to change, and it has to come from a community that has fresh ideas and is doing things in a new way. And I'll get to one of the things that we're tackling, but I think it's a wider problem that as a community we can tackle, and hopefully it's the kind of thing we can push upstream to change practices in sort of the more dinosaur part of the sector. So anyway, you have to deal with inconsistencies, and when you're dealing with inconsistencies, what you ultimately discover. So I come from a world in which people do all kinds of fancy optimization using neural networks and all kinds of other stuff. But underlying all of that is that nobody has good data. In fact, most of the optimization that happens around that is because of all of this manual effort that goes into extracting stuff, which is only ever a subset of the data that's out there. So when people say they're actually comparing and doing trade-offs, what you discover is it's within their local optimum. And finally, where does this actually spill over? This spills over into the full commercial perspective. So project risk, schedule slip, failure, all of these things are linked to where this data actually sits and how it percolates across the design lifecycle in one direction, but also different stakeholders in another direction. Because you have not just engineers interacting with this data, you have procurement people, you have business, you have legal. Yeah, I've seen some pretty crazy scenarios when I've talked to people about how this data gets transmitted. So this is where we decided, you know what, this is maybe something worth tackling. And basically what we concluded is that search in the space industry is broken. And this is not strange because if you consider where the industry came from and how it sort of popped up, you have all of these sort of regional ecosystems. And you'll often find that people say, oh, I know everything that's out there. But when I'm talking to people here in Delft, for instance, I typically ask them, if that's the kind of response, to name one company in India that has flight heritage. And after asking it more than 50 times, I've yet to get one answer. And that's when I tell them there's over 500 companies in the Indian space ecosystem that have flight heritage from multiple decades of working with ISRO, and it's all opaque. So there is really a problem here of fragmentation of knowledge and of data, and it's not by accident. That's the other thing. I mean, it's a discussion for another moment, but it's by design, actually, that it's that way. And it really requires a fresh look at things and a fresh perspective to change it. And finally, the most important point, and this is where I want to tag into for this community, is that this whole process is not democratic. So when we're talking about space, it is very much siloed, it's very much controlled. And in fact, talking to some of the larger traditional players, what we realized is there are good engineers everywhere, there's good procurement people, there's good business people, but the thing that they will never give you, they'll shoot you before you ever get anywhere near, is, for instance, their supply chain database. So they won't tell you anything about who they're buying from, who they're selling to, not because of anything else, then they know that that gives them an unfair advantage in the market. And why is this a problem worth solving? Well, if you believe things are growing and the industry is growing, then this problem is only getting worse. In fact, there are estimates that say, but it depends which studies you look at, that there's been more than 1,000 new space companies that have popped up in the last 10 years around the world. Not all of them successful, not all of them still around. But if you believe the hype, then this is a problem that's getting worse and worse. And what we really fundamentally believe, and this is almost at a philosophical level, is that the only way you can have sustained growth and really achieve all of these goals, lofty goals of going to Mars and settling and space stations and swarms of pocket cubes flying around and things like that, is an open supply chain. That's really, and unlocking the supply chain is really the key to real growth. So what we've been kind of putting together is this idea of a Google for space. So the de facto place where you go instead of Google to find the information that you're looking for, because you can find it in the form that you want, you can find up-to-date, reliable information. And the reason why we kind of pitch this as a marketplace is because it's a marketplace of knowledge. It's not so much that you're going to buy a part right off of a website, but it's rather that it's the place where you can broker the supply chain and where you can get access to what's going on in different parts of the world, what different suppliers are providing, etc. And ultimately, the goal here is we all want to design better space missions. Cheaper, faster, whatever it is that you want to consider in that realm as better, but I think that is a core goal of this. And I've heard in various presentations here about also sort of pushing the limits, and I think to push the limits, you need an open environment. And by that I don't mean everything has to be open source and it can't be anything proprietary, but rather that the supply chain caters to efficiencies that allow you to grow faster than the way we are today. And the thing that I'm here to talk about a little bit, which I believe is relevant to pocket cube design, is where we're actually changing this in terms of mission design. So if you go to our website now, you'll see sort of a search engine, you can browse around, and that's great. But the innovation really for us is what we're doing with the data underneath. So in the next few months, if you keep your eyes peeled on our announcements, you'll see that we'll be releasing an API. And that API will allow you to start doing stuff with data more intelligently than working with PDF documents. So one of the ideas, and I'll show you an example of this, that we're moving towards is sort of this idea of a drag and drop product library. So you open up SolidWorks, you're sitting in SolidWorks, there's a plugin there, you search for whatever part you're looking for, you drag and drop, and it comes with it all the specs that sit in that data sheet.
Including price?
I would love, and that's really the direction we have to go in, of course, is towards price and towards reliability and towards schedule and all kinds of other stuff. And we believe that there's a network effect there, because in the beginning, and we've noticed over the last couple of years, people are a little worried about this because it changes the landscape of the market. But we believe that there's kind of a critical mass that when it's there, you have at least sort of the knowledge that if you're not participating, you're losing out on something. And just to give you a brief idea, what we're doing under the hood, the USP is what we're doing with this unstructured data. So we're taking a lot from the world of computer science and what's being done in IT and in Silicon Valley, and all the stuff that goes into how you work with unstructured data and bring structure into it. That's what we're bringing sort of into this world, and in that way kind of bringing the two worlds closer together, the non-space and space side of things. And the core of all of that is what we're calling, what we refer to as electronic data sheets, and you'll see electronic data sheets mentioned in a few different contexts, and there are people in space even working on it. So we're kind of collaborating to figure out exactly what it is, and we have a sort of more lightweight version than has been discussed so far in the space industry. To facilitate all of this. And what is the big ocean idea here? The big ocean idea here is when data is in a form in which it's accessible, not only is it easier for humans and we save man hours and we're more efficient, etc. But when you make it accessible to algorithms, now we're really talking business. Now we can start doing the kinds of things that people have been talking about for not in the last couple of years, in the last 10, 20, 30 years, expert design systems, neural networks, AI, whatever you want to call it. But all of that has to be driven by data, because you train your models on data, you use data to calibrate things, you use data ultimately to design. So we believe that this is a kind of a fundamental link that's missing at the moment from the engineering side that will unlock a lot of advanced techniques that are necessary for us to end up on Mars. That's just the fact of the matter that I don't believe that unless we move forward even on the technical front and the design front, we'll ever do that sustainably. So this is what we're kind of calling integrated mission design. And the idea, very, very high level, is traditionally if you're sitting as an engineer, you have your simulation environment, your model, or whatever you're using. It could be mechanical, thermal, orbit. And somewhere there are a bunch of inputs that come in, and it generates your output. And from the output, you decide what you want to do with that concept, that design. So this is a pretty linear way it works today, and I have resorted to generating the inputs by opening a PDF and copy-pasting the numbers into a script or wherever else it is. What we're kind of working towards is this idea that if you have data in a form that's addressable by algorithms, you can have simulation and data sitting together, more or less at the same level in the design. And that allows you to do very rich design and experimentation with ideas and concepts as well. So I'm going to give you an example, if it will play here. I see maybe the video is blocked. Oh. All right, well, I'll maybe if I finish my talk in time, I can try and boot it up on, or change the settings on my laptop. So this is a video that I wanted to show you about what the traditional way of doing this is, and where you would end up today if you were trying to do the kind of search that I was talking about in a data sheet. And the next video was supposed to be, let's say, the future, which I see is also blocked. So maybe I'll finish the rest of the presentation and come back to this so that I don't run out of time. So skipping forward, the whole idea here, and I believe that's one of the inherent characteristics. So there's a lot of technical stuff related to pocket cubes, of course, and a lot of applications. But I think that as was probably the case with CubeSats, sort of vaguely remember the start of the CubeSat period, because I was doing my bachelor's here, I think there's also a spirit. There's a spirit of changing things, doing things differently, cooperation, and that wave, I think, is also worth investing in because it's a way to push forward the idea that space should be more democratic, that we should be a mainstream sector as opposed to this niche sector off in the corner somewhere, and that there are opportunities there to make use of, let's say, the momentum within the community to break some of the traditional ways of doing things that perhaps isn't in keeping with how we want space to be done moving forward. And basically what I wanted to ask out of this, and I'll try to get to the videos if we have some time, to show you directly what my idea was for with this for the PocketCube community. But the larger question here is, we're not building satellites, we're not designing satellites, that means us at SatSearch. But what we're trying to do is build ecosystem tools and productivity tools and things like that that help move things forward faster. So I would also solicit any and all feedback on what you see as perhaps tied to this, but if you have other ideas, I'd love to hear them as well, on what can help facilitate the community both grow but also advance on the technical side and perhaps even related to applications in business. Because I think that's a question that is worth answering because I believe that there are more than just a group of people who want to build satellites and interested in this. There is a whole swarm of people around that who are interested to get involved and don't necessarily know all the ins and outs to sit and solder something, but they have all kinds of other skills that they bring to the table. One of the main ones would be software that I would position as very important for this sector. How am I going on time?
Yes, you have.
I have time?
3 o'clock.
Okay, so
50 minutes. Okay.
I will quickly try to change. Actually, I'll leave. Can I film it on the video? Sorry, there were some questions as well. I think we can maybe.
I think it's great. It's a fantastic idea. It's been tried before several times. Never works. Don't get stuck in the price. Just ignore the price and just move forward. The trick is to get this tool out to the university professors,
Right.
so that they can understand what spacecraft can do. And they can apply, the problem is getting people to try to use the spacecraft. So there's a whole group of professors that want to, they just don't know how. And this tool could really enable that.
Yeah, and we have a close relationship with the faculty here as well. The
Well,
aerospace
not
engineering
just
department.
Delft, there's a whole world,
Absolutely. I've been told there's a whole world. All right, so let me see if I have the video plays up. So, if I can get this to work, I wanted to show you. Okay, so I'm kind of picking on the Alpha Orbital guys here. So this is an example of how, if you're on our website, you see it. So maybe you're interested in Alpha Orbital products, right? If you don't know it, now you do that you're listed. So there's a page, and there's information there. And lo and behold, there is a structure, which I think you guys have on your website as well. So the idea here is, okay, so this is the really low-hanging fruit. There's one place instead of going to 50 places or 100 places to find and source this information. This is where my password manager is.
We can't see over here.
Oh, sorry. So the idea here is, okay, so you can grab the datasheet off our website, and that's your datasheet. And I have to say, you guys have one of the nicer looking data sheets in the market. But the fact stays the same. You have this PDF document with some numbers in it. And we see a lot of people, we have people from all over the world. And I have some stats that I can show you either offline or even in the discussion if you're interested on where our users are coming from. We have users from more than 80% of the world now. And that's without really doing any marketing. And it's just taking advantage of Google and search engine optimization and stuff. So they're all coming for these PDFs at the moment. But one of the things, and next week we have an important launch there's another way of doing this, which is, so one of the partners we've been working with is a Belgian company called Raya, and they have this concurrent engineering tool called CDP. They have a community edition that's free, open source. You can go download it and play around with it. And it's a way of doing sort of this concurrent engineering process early on in the design where you're trying to test out different concepts and you have different disciplines being involved, you know, thermal, mechanical, orbit, whatever else it is. And they kind of address that layer of synchronization of all the different partners and stakeholders who are involved in that design process. But they recognized when we went to them that they have an issue as well, to some extent, that users start with a blank slate. So you have to enter data into the system. So what we are launching next week, which I'm giving you sort of a sneak preview of, if you can see here, this is their tool. So you can start it up as a systems engineer or whoever you are, log into the server, and then your data, everything that you do gets registered basically in the central server. And there are a number of other tools out there, and there are ones that are for preliminary design, but we're also talking to people who are in the detailed design phases where you also need supply chain data. On the left here you see, on the left you see the satellite tree kind of flattened down. They have this view in which you can see all the different nodes in the satellite and all the different properties. But as you see, there's all kinds of properties here, like mass, height, whatever else it is. And this either has to come out of your own database and system, which is almost always incomplete, inconsistent, or at least out of date. Or you have to do something else. And so now you see there's a little button there, which is going to be launched next week, SatSearch plugin. And so the same product that we just saw from you guys, Orbital. So you see them appear here. There's a description, you can see some of the characteristics of the product. This will essentially be a full-fledged search engine inside the tool. And what you just saw him do, Sam who created this, was drag and drop that product. And when he dragged and dropped that, it came with all the properties. So in this case, for demonstration purposes, there are only a few, but you can see there's mass, height, length, whatever else it is that you want. So this is to shortcut the whole process of what's going on with these data sheets. And I believe that we talk to people who work on traditional space systems, and there's always like a question of why, what, I'm so used to this kind of a thing. But I think that there's an age correlation, I have to say, as well. It's usually the younger, the more accepting they are of like things can be done a different way. Not always, but often. And so basically, to end with the question that I had at the end of the presentation, the idea here is this was just a small sort of prompt to suggest, maybe this is an interesting way to approach design. The idea here is also to sort of change the way traditional space design is done. So, we're not on timescales here of 10 years, 20 years. So you don't have a CDR, PDR necessarily in which you're handing off between teams and things like that. You maybe just want to get your hands on what's out there and figure out, like, do these things work together? Do they not work together? So the whole principle of this is to bring that data straight into the design environment so that you can do sort of a rapid concept generation and testing and speed up the whole design process. So that's my story in a nutshell, and there's a lot of interesting background stuff in this I can tell you about, but I'm happy to take questions, suggestions, or if you want to shut me down.
So I also met you at the Open Source CubeSat while we sat in a workshop and you were talking about some of this stuff. So am I right in my layman's understanding that perhaps a bit further down the roadmap of this, so like a lot of electronics components now in some of the EDAs have like footprint files and maybe even have like an object or an STL render file of the object. Is the idea that in your system then products going into the system can have those as well, and so as you drag and drop a load of stuff together, you actually get a decent model. Exactly. You can get a virtualized model of the product quickly.
That's really the idea and the direction. So this belongs to what we call our asset pipeline. So there's data, there's metadata, then there's sort of high-level specs, but then linked to that will be things like a step file, an STL file, whatever it is. There's another challenge. So there's a technical side of this, but of course you probably understand that getting that data from suppliers is another challenge in itself.
In a consistent form.
Yeah.
And also then, sorry, is the vendor, I'm just getting excited about the possibilities. Is further down the line that you leverage an AI at that, and you actually just chuck a set of requirements at it, and you get rid of all the design engineers, I'm going to make myself up, and then it builds itself from the system.
Yeah, I mean, I absolutely using algorithms, advanced algorithms. I think it's a little bit, how do I say? It's pushing things too far to say we're going to remove all designers out of the process, because I don't think algorithms are going to be that good for at least another generation or two. And I don't think they probably ever will be, because there's things like human intuition that are very difficult to reproduce in a computer. But I think it's about empowering the engineer. So if you are today spending, and we've done surveys where people have indicated, 10% of their time is spent wasted, searching on this stuff. Those are highly paid engineers Googling. And I think there's a better use of their time, and we can get to Mars or wherever it is faster if people aren't doing that and instead focusing on the difficult problems.
As mentioned, this has been done before, or at least attempted before. And the Achilles heel every time is product obsolescence. Data sheets are a simplistic product.
Yep.
If the product doesn't exist or the company doesn't
Yep.
exist, how are you going to keep up with the data stream? That is the Achilles heel.
Yeah, so that's a really good question, and that's part of, let's say, the non-technical challenge here is how to figure out a way. So there's only one way to do that, which is to incentivize suppliers to be a part of this. And there are ways that we can transparently do that. There are reasons why suppliers want to get in front of people. The same suppliers who are spending 10, 20K to go and stand in a conference booth and hand out 500 business cards, and they have no way of knowing, did anybody ever do anything with it until they get an email. We're in the digital age. There are things that can be done much better that way. So that's why we call it kind of a marketplace, because it's a marketplace for us as well. We have to address two sides. And the way we're focused on trying to do that, and we have some pushback for sure. Their suppliers are not particularly happy with this because they know it erodes some of the ways they work today. But there are others who are excited. And for us, it's kind of trying to crack that to figure out what is the incentive that allows us to scale. Because we're obviously not going to sit and update everything ourselves. It's just not manageable. But we believe that there are productivity tools on the supplier side to manage this data, because I've asked a number of people how they make these data sheets. Who's sitting in the office making these data sheets? It's almost always, I've heard, an intern and somebody who really would rather not be doing that. I've not really heard anyone who's enjoyed, waking up in the morning, I'm going to go make a data sheet or I'm going to update it. So I think there's some sort of productivity aspect to that, which we're trying to tap into. That'll hopefully help us crack maybe why it hasn't worked previously. And that, I think, is enabled by software and being digital.
Any further question? Yes. One.
Okay. Apart from shopping and Google, when I do procurement, I actually start with a whole bunch of specifications and then send it to a bunch of suppliers and say, can you build this one? Maybe a 5x5 printed circuit board with this type of strength and this type of weight, and I want it in orange, say. Now, that's how I would do my procurement. Then I request bids, and I would submit that on the leading edge of the space industry, we're more frequently in our design saying we need these specifications rather than what's being pulled off the shelf. So your system is telling us how to pull things off the shelf, but how does that respond to those that need custom design?
That's a good question, and you're kind of tapping into one of the features that I haven't mentioned very much about, but we've done some research into, is the reverse, which is being able to submit RFIs or RFQs through the system. And there's an incentive for suppliers to be in that back end, to be part of the process of getting that request. Of course, depending on who the buyer is, they might not be as interested if a student asks, but if it's a bigger company. So we are thinking about that, especially because we know that everything isn't commercially off-the-shelf standardized in space. There's still a lot of customization. But you at least have the opportunity to interact in that way, which isn't down to, did you happen to meet them at a conference and shake their hand? Did you happen to take them out for a drink? So it's just using and abusing, let's say, digital tools to do this in a more efficient way than flying everywhere. Anyway, any feedback I'd love to hear. afterwards as
Thank
well.
you. Have a good day.